Moving on, we are to look at the next rule, power of a power. So first, you should see on the left side of your formula, you have the parentheses, and inside the parentheses, you have a power, and it's in yellow, that's m, and outside of the parentheses, you have another power, n. So if you see that a power inside the parentheses to another power outside of the parentheses, you can simply to multiply the power and remove the parentheses, just whatever is on the right, a to the power of m times n. Let's look at the first example we have, 2 to the power 3 in parentheses squared, a power inside the parentheses and another power outside the parentheses. We are to remove the parentheses by directly multiply the power. So you should get 2 as the base to the power 3 times outside the power 2, and you should get your final answer as 2 as the base. 3 times 2 gives you 6. 2 to the power of 6. Moving on, x to the power 4, parentheses to the power of 5, power of a power inside the parentheses. So multiply x to the power 4 times by 5, and 4 times 5 should give you 20. So x to the power of 20. Last, we have the powers in alphabets. That's fine. You have a power inside the parentheses and one outside the parentheses, directly multiply. So 3 as the base, x multiplied by y, that should give you 3 to the power of xy. Moving on, we are to learn the power of a product. On the left-hand side of the formula, you see that inside the parentheses, you have a product a times b, and outside of the parentheses, you see they are raised to the power of n. So if you are to remove the parentheses in a product, you are to distribute the exponent n to each component inside the parentheses. So you should distribute it, and on the right-hand side, I believe that's what has been distributed, and the parenthesis is being removed. Let's look at the first example we have. We have the power s2, and now I am to remove the parenthesis of a product. I am to distribute the power 2 to each component. And if you are to look at the inside of the parenthesis, there are two components, 3 and a, respectively. So I am to distribute the power to 3. So you get 3 squared. And remember, each component is separated by the multiplication sign, and you have a. So you have a being squared. You are to distribute the power. So if you are to simplify, 3 squared should give you 9, and times a squared should give you a squared. And your answer should be 9a squared. Moving on to this example, you should first see there are three components inside the parentheses. They are x cubed, y, and z. So we are to distribute this power outside of the parentheses to each of the components of the product. Let's distribute the first component, x cubed. You put x cubed in a parenthesis, indicate the single object to the power 4, and y to the power 4, and each component is separated by this multiplication sign and z to the power of 4. And I believe if you are to look at your x cubed is a power to another power, so you are to multiply the powers. You have the power inside the parentheses multiplied by the power outside of the parentheses. So you have x to this power, and you have your y component, and since y is to its first power, so 1 times 4, you can just put y to the power 4, so as z to the power 4. And let's simplify the first component we have. So I believe x to the power of 3 times 4 gives you 12. So x to the power of 12, y to the power of 4, and z to the power of 4. Moving on, another version of the product, you have in fraction. And if you are to refer to a over b, and instead of a over b, you can write this in terms of a times 1 over b. So indeed, that a fraction is another version of the product. So let's learn the product rule in this fraction. So the rule is straightforward. If you have a fraction inside the parentheses to a power, you are to distribute the power to the numerator and the denominator. And if you refer to the right of the formula, I believe that should give you the answer. Now let's look at the first example we have. We have this expression inside the parentheses and is raised to the power 9. So we are to remove the parentheses by distributing it to the numerator and the denominator. So let's try to do that. So you put a2 and in a parenthesis to the power of 9, and then distribute to the denominator. You have b to the power of 9. If you refer to your numerator, I believe you should see a power to another. That is straightforward, right? So you are to multiply the powers in order for you to remove the power. So 2 times 9. And at the denominator is a bit straightforward. So b is power 1, so we just directly attach the 9. So if you are to simplify, I believe you should get your answer as a to the power of 18, 2 times 9, and b to the power of 9. That should be your final solution. And we have another one. This one is, you see, is more complex inside the parentheses, but we are to do it by removing the parentheses. We are to distribute the power. So 3y inside the parentheses to the power of 3, and you have 5x to the power of 4, and inside the parentheses to the power of 3. And this case is more complex because you see that this is a product, and then to another power, you are to use the product rule again and distribute the power 3. Let's look at the numerator. I believe you have two components inside the parentheses. You have 3, so you are to distribute the power 3 to 3. And you have component y. And at the denominator, I believe you have two components as well, 5 and x to the power 4. So you are to distribute the 3 to each component we have. So the first, you have 5 cubed, and then x to the power 4. So x to the power 4 inside the parentheses and to the power 3. Let's look at x to the power 4 inside the parentheses to the power 3. This is indeed a power of another. So we are to multiply the powers we have. So x to the power 4 times 3. And everything else remains the same. So let's start from 3 cubed. I believe that should give you 27. Y to the power 3. 5 cubed should give you 125. And the term here. The last, we are to simplify 4 times 3, and that should give us the final answer. 4 times 3 should give you 12. So let's simplify that. And this is your final answer.